Alright, I have one more example with the systems of equations, and this involves a little bit more difficult numbers. We're going to end up rounding these to some nice whole numbers so we don't have to deal with too much decimals, but be careful along the way, some of the numbers do get a little messy. So in this problem, I have Janet that blends coffee for a coffee house. And what she wants to do is she wants to prepare 280 pounds of blended coffee beans and sell it for $5.32 per pound. And the way she plans on making this mixture is she's going to blend together two different types of coffees. She's going to blend together a high-quality coffee that costs $6.25 per pound. And she's also going to blend together with that a cheaper coffee that only costs $3 per pound. So the question is, to the nearest pound, how much high-quality coffee bean and how much cheaper quality coffee bean should she mix in order to get this blend? Alright, let's set down some unknowns, see if we can figure this out. I will call Q the number of pounds and this will be for our high quality coffee. We'll let C be the number of pounds for our cheap quality coffee. Okay, so we're going to try and set up how many pounds of each of these we need. And one of the first bits of information that will really help out with that is we know that we have a total of 280 pounds. So the number of pounds for my high quality coffee plus the number of pounds for my cheaper coffee better equal 280 pounds. So this entire equation just deals with pounds. Now the second part will have to deal with the cost. We want the final mixture to be $5.32. So we'll use the cost of the high quality coffee bean and the cost of the low quality coffee bean to really blend the two together and get that final cost. So let's see what we have here. Normally, high quality coffee costs $6.25 for every pound of high quality coffee. And the cheaper coffee usually costs $3 a pound. And what we're hoping to make is $5.32 for that final 280 pounds of coffee. So let's mark this other one as just costs. So in our system here, you can see the numbers aren't quite as nice, but we can definitely still work with them. Let's do a little bit of cleaning up, and then we'll go ahead and try the substitution method on this system. I'm going to multiply these together first. So $5.32 times 280, giving me a new system that looks like this. 625Q plus $3 C equals 1489.6. Okay, so to use the substitution method, I'm going to take the first equation and let's go ahead and solve it for Q. This would give us that Q is equal to 280 minus C. And once we have that, we can go ahead and substitute it into our second equation. So $6.25. Q is 280 minus C plus $3 for C equals 1489.6. So our new equation only has C, and we can go ahead and solve for that. Let's distribute through by the $6.25 and see what we get. So 1750 minus 625 C plus 3C equals 1489.6. All right, looking good so far. Let's combine our C terms. Minus 325C equals 1489.6. Okay, so we almost have C all by itself. Let's get there by subtracting the 1750 from both sides. So negative 260.4. Right, almost there. One last step. Let's go ahead and divide both sides by the negative 3.25. Right, so I'm getting 80, and then something after the decimal, 1230769.2. It really just keeps going on and on. So I can see that I'm going to have just a little bit more than 80 pounds. But we want to round this to the nearest whole pound. So what I'll say is that C is about equal to 80 pounds. Now, once I know how many pounds the cheaper coffee will need, we can quickly go back to one of our originals and figure out how much of the high-quality coffee we need. Since I need the total poundage to be 280, and 80 of it will be into the cheaper coffee, then I know that the high-quality coffee, I will need 200 pounds. So our rounded solution, I have that 80 pounds of cheap coffee and 200 pounds of high-quality coffee. So if you really pick apart your word problems and try and set down an equation for some of the situations in there, you should be able to develop your system of equations just fine. Then use one of the methods we've learned, especially those algebraic methods, to solve the system, and don't forget to interpret your solution in the context of the problem. Thanks for watching Educator.com.